So we got this a direction vector, so it goes through a certain point in space, so it's going in a certain direction vector. So what can I call that line? A bit like a line that goes through a point on a two-dimensional space and has a slope of something. How do I write that line? It's a very similar thing. A vector equation looks like this. We use a point. We use all the points along it will be some multiplication of the direction vector based off that point. This is called a vector equation. I'll say that again. This is a vector equation. That is what. So with this information, that forms a vector equation.
So this is like y equals mx plus c?
Yeah, a bit, yeah. It's based off a position that we know is definitely on the line, and then all points, x, y, and z, will follow along the direction vector, but of different scalar magnitude. Does that make sense?
Is that the
So y equals mx plus c?
Yeah.
Oh, okay.
So is that the eigenvalue?
Eigenvalue.
What the hell is that?
It's just a lambda. It's just a, you could use a different letter there. They just usually use lambda. So this is a direction vector. Which means that vector equations aren't as unique as maybe y is mx plus c, because there's probably infinite amount of positions you could take along a vector equation, and you can have, in its simplest form, maybe this is simplest, but you could have a multiple of direction vectors as well. But the position could be anywhere position along.
What does the symbol mean?
It's any scalar multiple. It's just a scalar multiple symbol. So it could be in certain ones when we're talking about like an airplane going through the three-dimensional air or whatever, or just space. You use t here for time, so that the time would be its scalar multiple, depending how far it is along its distance. So this is a vector equation. That's how you write one. You need a position and a direction vector. What then is a parametric? So parametric form, parametric equation. It's based off this. It's when we look at each parameter, x, y, and z, separately, and we form just an equation that will help us find x, y, and z. So the parametric, maybe you'll see how I form this. That's a terrible lambda. It's not running it. We see where we're getting this from? It's just breaking down each direction into how it's found using lambda. So any x value would be 1 plus 4 times the lambda. How did I get that? Well, I went x, 1 is its position, and lambda times 4. Y is minus 2 position, lambda times 5. And z, 3, lambda times -6. This is called the parametric equation, or parametric form, which just deals with each parameter x, y, and z separately and gives a separate equation for all three.
Why?
It's useful for if you're dealing with individual coordinate or something like that, rather than having to deal with all of them at once. You just deal with one at a time.
We've done Cartesian, right?
You've done Cartesian? No, not the way you were going to see it now, but yeah, you kind of have. Cartesian form is the other.
This is.
Cartesian form is removing the lambda. What would it look like if we removed the lambda? So lambda is the only constant across the board here, or t, or wherever this letter is. It's the only constant across the board. It's the only thing that wouldn't change from each one of the parametric equations. It's the only thing that multiplies each one here. So Cartesian equation is letting all those equal each other from parametric form. So I could rearrange this so lambda equals, rearrange this so lambda equals, and rearrange this so lambda equals, so they all equal each other. So x minus 1 divided by 4 is the same as y plus 2 divided by 5 is the same as z minus 3 divided by -6. That's a relationship between x, y, and z then. Cartesian, yes, z. Yes, I put a z. Okay, they are the three different forms. They have this one is more. This one's more useful if you're trying to talk about specific points. This one is. What's this one more useful for? This one's more useful if you like know what lambda is, and then you're trying to also find specific points. But it's always about trying to find specific points. And this one kind of ties them all together, and you want to look at it through geometric space. Okay, so let's follow up with some questions. So find the parametric equation. So here we are. This asks them to find this style given two position vectors. So we got this position vector 1, 2, minus 1, 4, and B is minus 1, 0, 2. All right. If I have two position vectors, how do I get the Cartesian?
We need to get the direction first.
Choose one. Yeah, so we get the direction from A to B. So
-3.
Yeah, so we go A to B, so that's going to give -3, +1,
-2.
-2. Okay, so that is now a direction vector. If you want, you can put it in this vector equation form first. Maybe that's easiest, and then transform it into this form. Maybe that would be something we can do. So we'll do that. So that's a direction vector. So if I times that by lambda, a position vector, I can use either of the two. We happy with that?
So this is just any point that's on the same line that crosses those two. On the same direction vector that crosses those two points.
Say that again.
So this equation finds the point of any.
Yeah,
like
finds
of
all
any
the
point
points.
that's on,
Yeah.
of all the points that's
It's
on.
the same as y is 2x plus 3 gives all the points along that line if you know the
Yeah.
x value. This one, if you know the x value, you won't necessarily be able to find, or you could, yeah, lambda you could find with what the z value and the y value.
Well, why is it in terms of the lambda though? Why
It's a constant, because
So if you think about it, any point is going to be some distance and direction
Oh,
away from
yeah,
this
right.
point, and this determines the distance and direction. It's going to be notice like infinite, so we just put lambda there.
It can even
So
be
this is like the slope, and this is something.
It can even be like decimal.
Yeah.
And
Yeah, it's anywhere. Okay, so that is so we got our position vector, we got our direction vector, and we have just x, y, and z's in terms of these three. That's a vector equation. It's not in Cartesian form, but I think it's usually easier to go through the step to get to here, but maybe we can do it without that.
You just like circle each one. Just like x equals.
Yeah, so x is 2
minus
all right,
9.
so let's put it in parametric form. X is 2 minus 3 lambda. Y is minus 1 plus lambda. And z is 4 minus 2 lambda. And then, okay, this is in parametric form. Let's get it everything equal to each other because we have something equivalent in each one. X minus 2 over -3 is the same as y plus 1 over 1. Don't need the over 1. Is the same as z minus 4 over -2. And this is the answer we wanted.
Nice.
why is the lambda
Okay.
in front of the direction?
It's just parametric equations.
Oh, you're too far.
Oops. Yes, I did Cartesian. I read this.
Oh.
That was it. Well, we did all three.